here. I'm not going to, but I am only writing the code for here. Now move R5 A0 plus. What will be the content of R5 now? What will be the content of R5?
2000.
No. A0 is pointing to okay. No. Memory is your source or memory is your destination?
Destination memory source है.
Memory is your source. Memory is your source. So actually A0 is pointing to 100. 100 contains what?
0 should point to $200.
Okay. We don't need this. I'm sorry because I made one mistake. We don't need this control here. I will explain this why. We don't need control. Not 1006. Okay, we need this information. The first one is your source, and the second one is your destination. So now in this case, what is your source now? Source is your IO. So it is pointing to this location. A1 is done, it is your source. It is now your destination. Okay. We doesn't need $1006 and it's your count. What is your count now? 100. So move R3 $1006. So R3 is now your count register. R3 is now your count register. So what is the contents of R3 now? 100. Okay. Now what is our source? It is our source. So we can say move R5 A0 plus. What will be the value of R5 now? E0. So its contents will be E0. And then what will be the contents of A0 then after this? Why? Because we want to move the next level. Move R5. But now we need to move this value am I right or not? We want to move this value from the source to the destination. Destination is pointing to where? What is the content of A1? 1004? 300? It is pointing to this location. So this value will be moved into register R5. When it's moved into R5, so now we are transferring this data. The memory is your source or destination here? Destination. What will be this content now? Okay. Then now what should we do now? Decrement R3. Decrement R3. Then compare R3 with what? 0. When it's not equal, jump to which level?
Move R5.
Transfer. Okay. Now if you look at this code, I will now explain it again because now the problems were a little bit diluted. Okay. Now in this case, what is our objective? Our objective is to transfer the data from the IO device to the memory. So in this case, this will be some memory map of the IO device, and this memory map of the IO device will mention 3 addresses. One is the $1000 will contain the
Start.
source address start. $1004 will contain the destination, address, start. The base address. We call it the base address of your source and the base address of the destination. We call it the base address of source, and it's called as the base address of what? Destination. And then the other parameter 1008, it will contain what? Count. So what now we have moved A0. A0 is pointing to the source. What is your source? A0 is pointing to your source, and source is what? IO. A1 is pointing to the destination. Destination is your what? Memory. And now this address is $1008. Now this R3 is your count.
Yes, sir.
It is updated in your count. This is R3. Now we are moving the data. First we move the data to a register. Then we move this data to the. We move the data from the IO device to the register. And then we move the data from the register to the memory. Then we decrement R3. Now. And when it's done, what should be your last instruction?
And
Last instruction. ISR. What should be the last? RTI. Return from interrupt. Okay. Now, what point I want to raise here? Interrupt-driven I/O is better compared to the program control I/O because it does not check the status of the device again and
again.
again. Whenever the device has some data, it will generate an interrupt to the microprocessor. When it generates an interrupt to the microprocessor will acknowledge the device. When it generates an interrupt, so it will give some information what kind of service I need. In this example, the I device says, now we need to transfer 100 elements
From memory to IO.
from the IO device
To memory.
to the memory. And how many number of elements are there? 100. Now this information is provided to the microprocessor through these registers. What are these registers? Status register or control register. Okay, this information is given to the microprocessor. Microprocessor when jump to the ISR, when it jump to the ISR, it knows, okay, now we have the starting address of the IO device, the source address, now we have the destination address. Okay, now if you want to reverse the mechanism, if you want to transfer 100 elements from memory to IO device, what changes we need to make?
सिर्फ ये जो 0 और 1 के जो changes है और
This value will be here, this value will be. So you need to provide this information. What is your source address? What is your destination address? And how many elements you want to? But this mechanism has still a disadvantage because it requires a transfer of the data from the
through the microprocessor.
from the IO device to the microprocessor and from the microprocessor to the memory. And in case of if you want to transfer this data to this data, first you will transfer it from the memory to the
Processor.
microprocessor and from microprocessor to the. Even if we change this, okay, now if we can replace these two by this also. We can also write it like this. Move because A1 is what? A1 is your destination.
Yes, sir.
It is your
Source.
But if you look at this instruction, first microprocessor will fetch this instruction. This will decode the instruction. Then it will fetch the operand. It will fetch the operand. What is your operand? This is your operand. This operand, microprocessor will go on the address lines. It will access the address. It will dash it within the microprocessor, temporary register, and then microprocessor will transfer this data to the IO device. But this mechanism requires the involvement of microprocessor for the transfer of data from the IO device to the memory, or from memory to the IO device. method efficient or inefficient?
Cycle line is not that
Because this is inefficient in the sense. Okay, this method is better than the program controller. Because if the device is not ready for 100 seconds, so microprocessor will continuously check the status. But now in this case, when the device is ready, it will interrupt the microprocessor. And it will give the necessary information. It will give the source address, it will give the destination address, and it will also give this the number of counts or something like that.
नमाज का ब्रेक ले लो
Okay, for the transfer of this data, how we can solve this problem?
प्रोसेसर को बाईपास करके डायरेक्टली
If you now I will explain this to an example. Now let's assume these are the contents of the IO device or memory map of that. This is from the memory. And if we want to transfer this data from here to here, okay, so now what I can do, I can ask this student, okay, please come here and then sit here. And then second student come here and sit here. In this case, microprocessor is just transferring the data. It's doing nothing. It is doing nothing. But I can delegate my authority to the CR. Okay, I can go and teach in another class, and I may ask here to do this transfer directly without the involvement of the microprocessor. So in this case, this value was first read from here to here, and then it was written from here to here. So now in this case, microprocessor may ask the IO device, okay, we will not transfer the data, you can directly transfer from here to here, and I am not involved. This mechanism is called as direct memory access, and we will explain this in the next lecture. Okay.